Thanks to the Human Microbiome Project and thanks to the fact that we can use PCR and other RNA testing, we now know that there are bacteria in places where we just could not conceive that they would exist. And one of the scary things is people, for instance, with dementia have up to 4-fold more bacteria in their brain than hopefully you and I do. And if they're there, no wonder our microglia are activated. Wow.
Well, hey everyone, Dr. David Perlmutter here. The gut is connected to the brain. We've heard of this gut-brain connection, and it is so fundamental for a number of reasons. First of all, the relationship between things going on in the gut and how the brain works day to day. But I think more importantly, when things go wrong in the gut, how that paves the way for issues related to the brain, including neurodegenerative conditions and even mood disorders, things like anxiety and depression. Been writing about the gut-brain connection and the brain-gut connection for an awful long time. There's a new book that I just reviewed. It's called The Gut-Brain Connection. Here it is by Dr. Stephen Gundry. Dr. Gundry, as you know, is a cardiologist, cardiovascular surgeon, has been on our program before. A very interesting individual and certainly a very interesting book. Let me tell you a little bit more about Dr. Gundry. Stephen Gundry, MD, is the director of the International Heart and Lung Institute in Palm Springs, California, and the founder and director of the Center for Restorative Medicine, also in Palm Springs and also in Santa Barbara. After a distinguished surgical career as a professor and chairman of cardiothoracic surgery at Loma Linda University, Dr. Gundry changed his focus to curing modern diseases via dietary changes. His best-selling books include Gut Check, Unlocking the Keto Code, The Energy Paradox, The Plant Paradox Family Cookbook, The Longevity Paradox, The Plant Paradox Quick and Easy, The Plant Paradox Cookbook, and The Plant Paradox. And he's written more than 300 articles published in peer-reviewed journals on using diet and supplements to eliminate heart disease, diabetes, autoimmune conditions, and multiple other diseases. He is the host of the top-ranked nutritional podcast, the Gundry Podcast, and founder of Gundry MD, a wellness brand. Dr. Gundry lives with his wife, Penny, and their dogs in Palm Springs and Montecito, California, and very excited to have Dr. Gundry back here on the Empowering Neurologist. Stephen Gundry, good to see you.
David, great to see you again, my friend.
Welcome back. I think the last time we saw each other was on your podcast, and then before that we were lecturing somewhere together. It's been a long time. Yeah. Anyhow, congratulations on the new book, The Gut-Brain Paradox. So what's a guy in cardiology talking about the gut and brain connection? What's that all about?
Well, you know, you and I and Dale Bredesen have reminisced about exactly this. It's like, what are two brain doctors doing down in the gut, and what's a heart doctor doing in the gut? And we, I guess, all have come to the realization that Hippocrates, the father of medicine, 2,500 years ago said all disease begins in the gut. And we're just slow learners, I guess. He was right.
It's true. In neurology school, I think cardiology school, we didn't learn much about the gut except, how to treat inflammatory bowel disease, et cetera. But you jumped right in. You did a great job. And, as usual, your books are so understandable. And I'm very, very excited about this one. You have a great dedication at the beginning of the book to Semmelweis. And, one of my heroes, obviously one of your heroes. Tell us very briefly that story, because I think it lends itself to what we're going to talk about today.
Yeah, actually, before I talk about him, many people have seen the movie Moneyball about a guy, a true story about the Oakland Athletics, who used basically computer assessment of how good or bad ball players were in helping a team. Long story short, using this with a really cheap team, the Oakland A's went to the World Series, and the manager was recruited to come and manage the Boston Red Sox. And in one of the final scenes of the movie, this manager was hated by all the other baseball owners. And so the owner of the Red Sox says, I want you to manage my team. He says, no, you don't want me. He says, I am so hated because of what I've done. He says, you got to understand, those who go through the wall first are always bloodied. And that really had an interesting effect on me, and I'm sure you, and those of us who go through the wall first. So getting back to Semmelweis.
But let's get to Semmelweis in 1 second, because a thought comes to my mind, a similar kind of inspiration for me. Over the years, I became friends with Amar Bose of Bose Audio. And he said, come to my place in Boston, outside of Boston, where we build all these cool Bose things, sound canceling headphones, and all kinds of things, stereos, etc. And as you walk into his glass office, there was a quote on the glass. It said, "At every crossroads that leads to the future, each progressive spirit is confronted by 1,000 men appointed to defend the past." So let's segue that one into Semmelweis, because he certainly was went rub people the wrong way.
Yeah, he was actually a medical student at Vienna Hospital. And he, at that time, professors did autopsies, and then they immediately left the autopsy theater and went and, for instance, delivered babies. And one of his professors cut his finger during an autopsy and actually died of sepsis from that little finger cut. Now, this was before bacteria were discovered, known about. But Semmelweis was very impressed with that. And in Vienna, there was also a midwife hospital where midwives delivered babies. And at that time, puerperal sepsis, childbirth sepsis, was really the leading cause of death of childbirth. And these women would get horrible infections. The midwives did not have that issue, and it was only in the university. And so Semmelweis said, gee, I think, the midwives aren't doing autopsies, and I think my professors are bringing something from these autopsies, and they're not washing their hands or doing anything because, why would you? And they're introducing something that's causing this problem. So when he became on staff, he mimicked the midwives, and he actually washed his hands and made all of his people wash their hands. And almost instantaneously, his results got a whole lot better than all of his other colleagues. Now, you're right. That goes against conventional wisdom. That goes against teaching, and it actually, it becomes a threat to these people. They were so powerful that he was literally exiled to Budapest, and he was declared insane because of his beliefs, and he was beaten to death in the insane asylum.
And died from an infection, too.
Yeah.
Of
And
all things.
the amazing thing is, of course, 15 years after his death, bacteria were discovered. And then, of course, he eventually really was hailed as one of the fathers of antisepsis.
Amazing. Well, once you jump into the book, I was surprised. Your first case was Parkinson's disease. So walk us through that. I mean, why, Stephen Gundry, are you thinking about the gut in a patient you're seeing with Parkinson's disease? And how did that all play out?
Yeah, so in fact, I just saw her actually about 3 weeks ago again. And I'll tell you an interesting story about her, which nobody has heard this except you and your listeners. So this was a young woman, 62 years old. She's a physician.
Very young.
Very young, 62 years old, who had developed really bad Parkinson's. She was a marathon runner. She had had Parkinson's now for about 5 years when I met her. She was pretty much immobile. The drugs were no longer having much of an effect for her. Classic mask of Parkinson's. And she actually sat in a chair, and her husband did most of the talking. Bless you. So she was sitting in a chair, really didn't do any talking. Her husband did all the talking. And we, uh, my nurse practitioner had seen her first, and we had done leaky gut tests on her, which we do. And she, in fact, had gut dysbiosis and leaky gut and a lot of, inflammatory markers. So we put her on my program that I talk about in the book. And my nurse practitioner saw her by phone about 6 months later, and she seemed to be improving. And then I saw her a year later, and I literally walked into the exam room, and I didn't recognize her. She had a smile on her face. She did not have a tremor. She had a really bad tremor. And her husband jumps up and, literally grabs me and looks into my eyes and says, "Oh, thank you for giving me my wife back. This is the girl I married." And she said, "She's running. I can't keep up with her." And, and we're all crying eventually. And so, you did it. And her blood test, her leaky gut was gone. And, we're celebrating. So it's an amazing, amazing story. And you do what you do, and I do what I do, because we get these miracles, what you and I would have considered a miracle 30 years ago. So this really is interesting. So I saw them about 3 weeks ago, and we had our leaky gut test, and she had not bad leaky gut, but she definitely had leaky gut again. And she had several antibodies to gluten that she hadn't before. She started with lots of antibodies to gluten. And I walked in, and she said, I said, "How you doing?" And she still looked great, and she didn't have a tremor. She said, "I don't know. I think I'm slipping. I think I'm slipping." And I said, "So you feel it too?" She said, "Yeah, I know I'm slipping." And I said, "Well, as a matter of fact, we can see it on your gut test." I said, "Something's changed." And her husband, we go, "Something's changed. What?" "I don't think you're eating gluten. I don't think you're purposely sabotaging yourself. You know too much." They said, "No." And then the husband says, "Son of a gun. Our son, who's in his 30s, moved back in with us. And we share a cutting board. And he slices his bread on the cutting board. And we slice our stuff on that cutting board." He said, "And you're right. Her downhill that she felt started shortly after he arrived." Now, that sounds, if you and I had heard that story probably 25 years ago, that sounds preposterous that this could happen. And I think, at least I know, working with my patients, and that in some of these canaries, just exposure to little bits of these mischief makers can cause this issue. And again, I've not told this story, but she knew something was different. And so anyhow, we're getting rid of the sun.
So, to connect dots here, you're working on fixing the epithelium, the one cell barrier of the lining of the gut, in order to bring about an improvement in a neurodegenerative disorder, in this case, Parkinson's disease. That sounds far fetched
It
to,
sure
to
does.
some. I mean, not to me, but it does seem far fetched. Having said that, let me backtrack a little bit. When you say you test for leaky gut, how do you do that?
Well, I use Vibrant America, Vibrant Wellness tests. their test is poorly named. It's called the wheat zoomer, but there are other people that do it. I look for anti-zonulin IgG, and I look for anti-actin IgG, and I look for anti-LPS IgG.
So you are looking for LPS serum antibodies.
Yes. Yeah.
Okay. And so for our viewers, just to get an understanding, you're looking at the evidence that LPS, lipopolysaccharide, that is the covering over gram-negative organisms living in the gut, somehow, because the gut is leaky, made its way through that one-cell thick barrier and then challenged the immune system. The immune system mounts a reaction, and that reaction is something you're measuring. Then you're backtracking and saying, okay, therefore the gut is leaky. So you're correlating then this leakiness then to her clinical worsening.
Yeah.
And, it is so straightforward and clear to me, but I mean, here we are in 2025, and it's still going to raise a lot of eyebrows, but that's okay. It's what we do. And having said that, so then she was able to identify the cutting board or whatever it may have been. What happens after that?
So what we're going to do in about 2 more months, we're going to repeat these tests and let's see what happens. Let's see what happens to her symptomatically. Usually, about 80% of my practice is autoimmune disease. I happen to think realistically coronary artery disease is an autoimmune disease. And let's call Parkinson's or Alzheimer's an autoimmune disease. I'm comfortable doing that. Most people aren't, but it's an activation of our immune system.
Okay, and in that regard, I think if you can open that up a little bit more in talking about glial cell activation, the brain's innate immune system, that would be a good thing. And how then does that relate to leaky bowel?
So I think, and I talk a lot about this in the book, and you know this, but if our bowel becomes leaky probably every day, and luckily we have a pretty good mechanism back in the good old days to repair it very quickly. So these local incursions across the border are handled very easily. In most of us, we no longer have a defense system against the foods we eat and the toxins in our environment to handle these. And so, for most of us, the wall of our gut is constantly being penetrated by foreign particles. And, 80% of our immune cells, our white blood cells, are down in our gut. And with this battle, they alert our glial cells, the bodyguards of our neurons in the brain, that there's trouble down here. The hordes have come across the border and they're on the way. And prepare yourselves, protect yourselves, protect the neurons that you're supposed to be guarding. I've recently used the analogy, which I kind of like a lot. And as you know, we've wasted a large amount of money going after the amyloid plaque and tau protein theory of Alzheimer's. How many $billion have we wasted so far?
Several. I mean, at least one company alone, 1.8 billion in research, and then they shut it down.
Yeah.
But just let me just open that up a little bit. The prevailing theory that we are told to believe is that this accumulation of beta amyloid is the cause of Alzheimer's disease, and if we can eradicate beta amyloid, all will be well. Well, now there have been the development of drugs that actually do a pretty good job at ridding the brain of beta amyloid, and yet patients continue to decline. What does it tell us? It tells us exactly what Dr. Gundry is saying right now, that this is not the cause of Alzheimer's disease.
Yeah, it's not. So think about 9/11. After 9/11, we were so worried about terrorists attacking us that we put barriers in front of federal buildings, in front of airports, in front of anything that could mow down a pedestrian. Well, I like to tell my patients, guess what? When your guards up in your brain get alerted that terrorists are on the way, you start throwing barriers in their way. You put up barriers. And I like them to visualize that Beta-amyloid and tau proteins are just these concrete barriers that are trying to protect the neurons from mischief. And Dale Bredesen loves the infectious disease theory of Alzheimer's, but I think that all ties together. So you're just trying to put barriers in front of the neurons, and as you know, and I know, these microglial cells get so crazed in trying to protect the neurons that they literally, like Pac-Man, eat these dendritic processes back. They pull all the lookouts back to the fort and then surround the fort and to protect the neuron. And if all these dendritic processes are pruned back, no wonder you can't remember anything.
CRS syndrome. You can't remember stuff. We'll leave it at that. But I think to really sew this up, we've got to just make that connection then between the production of inflammatory chemicals from the fact that the gut is leaky, the immune system is activated, the ability of those inflammatory chemicals called cytokines to get through the blood-brain barrier, and then how they affect these microglial immune surveillance cells to actually lead to problems. You talk in the book, and I think it's going to be very interesting for readers to embrace this, of a brain microbiome. I mean,
Yeah.
that is, it was hard enough to relate to the gut, but now you're actually describing organisms that reside in the brain. And, most people, I think, would conceive of the brain as being a pretty sterile environment.
Yeah, we were certainly taught that. For instance, we were taught that the placenta, for instance, is sterile. And yet now, thanks to the Human Microbiome Project and thanks to the fact that we can use PCR and other RNA testing, we now know that there are bacteria in places where we just could not conceive that they would exist. And one of the scary things is people, for instance, with dementia, have up to fourfold more bacteria in their brain than hopefully you and I do. Uh, and and if they're there, no wonder our microglia are activated. Wow.
And beta amyloid too. I mean, to get
Exactly.
back to your, your comment about beta amyloid, Rudolph Tanzi, I think, made it very clear that beta amyloid acts as an AMP, antimicrobial peptide,
Yep.
and the enemy of my enemy is my friend. And yet, as you mentioned, the billions of dollars that are being dedicated to targeting and the amyloid in the brain and ridding the brain, when it's the problem is upstream of that. It's the inflammation, the reactive oxygen species, as a consequence of microglial activation. Well, hi, everyone. Dr. David Perlmutter here. We hope you're enjoying this content. And if you would do so, go ahead and hit the like button. And if you're not already a subscriber to our channel, please consider doing so. We're really grateful to have you as part of our community. So let's get right back to the presentation. So we've talked about Parkinson's and the relationship of that to the gut of all things. And I think to sew that one up, we see in the area of the brain, the substantia nigra, that makes the very dopamine that is deficient in the Parkinson's brain, that this is an area basically under attack by our own immune system. To get back to your contention that we should consider rather Parkinson's as an autoimmune condition, and you're targeting the gut. It's incredible. You're targeting the gut to rein in immunity and cool things down a bit. And you've seen this incredible benefit in Parkinson's. It's pretty dramatic.
Yeah, my father had Parkinson's for about 25 years. And when he first developed it, I was just kind of starting in this. And he did not change in 25 years, did not change his medication, did not change because I taught my mother um, to feed him, I guess. And funny, I'll tell you a funny story. We did blood work on him, and we'd see sometimes he'd get a bit worse. And my dad, they lived in San Diego, and my dad walked their dog twice a day, and he was friends with all the neighbors. And we'd see this on his blood work, and my mother would say, something's worse with him. And it turns out that my father was such a likable guy that he would actually, my mother wouldn't give him grains or carbohydrates or sugars. So he would knock on neighbors' doors and seriously, and they go,
Feed
"Oh,
me.
yeah, oh, Bob, and the dog, oh, would you like a cookie? Oh,
Sure
sure."
it would.
And so we actually had to go around because I knew all the neighbors as well. We had to go door to door and say, "Don't feed the animals, including Bob." And so, he would seek this stuff out. But yeah, he did. He had Parkinson's for 25 years and died of a totally different reason at 91.
We could spend more time on neurodegenerative conditions, and recognize that in fact you can pretty well fingerprint the gut microbiome now,
Oh yeah.
and relate it to things like Alzheimer's and Parkinson's. But I would like to shift laterally to mood disorders, because you do cover that, and I think that may raise eyebrows as well. The notion that targeting the gut might give you some clinical efficacy as it relates to treating mood disorders. Can we open that up a little bit?
Yeah. I think one of the things that we've learned from the Microbiome Project is that, first of all, you and I were taught that neurotransmitters and dopamine and serotonin, et cetera, were made by neurons or even then neurons in the gut. And then lo and behold, we find out that it's the gut microbiome themselves that are producing these neurotransmitters or the precursors. And then to come to find out that these tryptophan pathway bacteria are selectively killed by glyphosate, the active ingredient in Roundup, then you start going, wait a minute. And Roundup was patented as an antibiotic. It wasn't a weed killer. So you go, wait a minute. And Roundup's in everything now, glyphosate's in everything. And so, oh my gosh, we've killed off this tryptophan pathway bacteria. And no wonder we don't have, a lot of feel good feelings. The other thing that you and I both know is that if serotonin reuptake inhibitors, SSRIs, actually worked by preventing the degradation of serotonin in the brain, then you and I could pop a Prozac and tomorrow we'd be giddy with laughter and happy, happy, happy. And we know from our patients that that isn't the case, that it can take a month or more to have an effect. And lo and behold, we now know that these drugs actually change the microbiome to a more favorable tryptophan pathway microbiome. And so even these drugs, the effect was actually on the microbiome. And we know from animal experiments that we can take a happy rat and have it eat poop from a depressed individual, and the rat will become depressed. We joke rats love to eat poop, so and conversely, we can take a happy people's microbiome and have a depressed rat eat that, and they'll become happy.
Do you ever wonder how they determine if a rat is happy or depressed? I know that they do, and I know that this is validated, but I've
It's actually how it seeks out its environment, how much it's
and
willing
how
to
it
explore.
explores.
Yeah,
Yeah,
it's an
whether it
exploration thing. Yeah.
so I then to extrapolate from what you're describing, then there's the opportunity then to reestablish a healthy microbiome as a way of improving mood, as a way of dealing with, for example, depression.
Yeah. Um, a ton of my patients, particularly women who see me for autoimmune diseases, they're on one or two antidepressants when I meet them. And they've been on them for so long that often they don't even put depression on one of their symptoms or diseases. And a lot of them, will say, geez, I've been on for so long. I've tried to get off. I can't. I need them. And I said, well, you might find that we're not going to need them as we go along. And I profile a woman in the book, one of many, and they have leaky gut and they have intestinal dysbiosis. And as we repair their gut as we get their dysbiosis, get the terrain back to a vital tropical rainforest, if you will. All of a sudden, many of them, unsolicited from me, go, don't get mad at me, but I stopped my antidepressants. Now, please don't stop antidepressants instantaneously, please. But the point is, they didn't need them anymore because their gut was now producing the right signals, the right signaling molecules. And that's exciting.
You even talk about a microbiome that correlates with addiction.
That was one of the real, I think, shockers to me. And it's actually so exciting to me that I've actually had a few psychiatrists at rehab centers approach me to start doing some studies on this. It is shocking that there's a nicotine microbiome, there's an alcohol-seeking microbiome, there's an opioid-seeking microbiome, there's even an NSAID-seeking microbiome. And most of these bacteria are seeking more of these substances, and they use pain to get you to get more of those substances. And the more pain they cause by leaky gut, the more you take and the more they take of that substance. And I mean, there's actually beautiful work in human studies with alcohol rehab. People who have the most dysbiotic alcohol-seeking microbiome are the biggest failures in treatment, and the people who have the least alcohol secret microbiome are the best chances to make it through. And imagine if we knew that, going in, that we could foster, we're going to treat your addiction by changing your microbiome, by healing your leaky gut. And the evidence in opioids is even probably more scary. These opioid-seeking bacteria want these substances, and they'll consume more of it, and you need more and more of the substance to get the same effect. And so what they've done, again, in experimental animals, they'll wipe out this opioid-seeking microbiome with antibiotics. And then kind of instantly, these animals, a tiny dose of a narcotic is enough to give an effect. Then you reintroduce this opioid-seeking microbiome, and instantly, I mean, the next day, they're back to, oh my gosh, I need this huge dose to have the same effect. And it's just, it's mind-blowing that.
That they find these bacteria have domesticated humans for their own desires. And you even talk about hunger. I think you call it hunger being hijacked by the microbiome. That's going to be surprising for a lot of people that we'll get to metabolism in a moment, but that their hunger, their behavior is being manipulated. Bacteria are manipulating human behavior for their own desires.
Yeah. I mean, we can get into woo-woo stuff, but bacteria have been around for 3 billion years, and we've been around for 100,000. And we realize that we are a symbiotic organism that's dependent on our bacteria and other guys. But the degree that dysbiosis, that bad guys can hijack our thinking, is anathema to us smart creatures. But as you and I know, and I wrote about in a previous book, toxoplasmosis is the classic.
You got to walk us through it. That's a beautiful example and fascinating.
Yeah, I learned this. One of my heroes when I first started getting into this, actually in college, was a professor at Stanford by the name of Robert Sapolsky. And Sapolsky, if anyone doesn't know of him, he does a beautiful lecture on YouTube about toxoplasmosis. So toxoplasmosis, a lot of parasites have a life cycle where they need an intermediate host to get into their final resting place host. And toxoplasmosis is this little protozoa, single cell creature that wants to get into the brain of a cat, of any feline. And it chooses as its intermediate host the worst choice in the world. It's a rat. And if you think about it, rats hate cats. They're scared of cats. The smell of cat urine makes them run in the other direction. The sight of a cat makes them run. Toxoplasmosis gets into a rodent by drinking cat feces, contaminated water. Toxoplasmosis goes to the brain of the rat and using the dopamine pathway, simplistically rewires the brain of this advanced organism to love the smell of cat urine, to get sexually excited by cat urine and the sight of a cat, and to run to find that cat, run to danger. And of course, the cat eats the rodent and the life cycle is completed. Now, what got me so interested is when we know that chimpanzees can be infected with toxoplasmosis. Why in the world why bother to infect a chimp with toxoplasmosis? Well, in Africa, chimps are one of the favorite targets for big cats. And we know in Yellowstone Park that most of the pack leaders in Yellowstone Park are infected with toxoplasmosis. Why? Because they're willing to take risks. Why would you infect a wolf? Because the only predator for a wolf is a cougar. They have no other predators, a cat. Humans are infected with toxoplasmosis because, believe it or not, in India, we happen to be a delightful morsel for big cats, for tigers. What a great way to manipulate a human to get us into a cat. And what's really wild is that
No,
most motorcycle accident victims are infected with toxoplasmosis.
yeah, and so let's get back, and we'll get back to that. But the notion that the alpha male in the wolf pack is far more likely to be infected with toxo in comparison to the wolves who follow that alpha male. Think this through, and that this all and what you just mentioned with respect to motorcyclists is very, very interesting in terms of risk taking being induced by the presence of this type of infection. I mean, I don't want to say mind blowing. That's obviously it is mind blowing.
It is.
But I'm so glad you were able to extrapolate that from Robert Sapolsky's work, who, I think for many of us really opened our eyes to appreciate how behavior changes based upon environment. His work with stressing primates and cortisol levels and changes in the size of the hippocampus based upon that stress. Why zebras don't get cancer. Some amazing work. I'd like to reach out to him, but we got there, I think, through the notion of organisms affecting our behavior. We think we are in charge here, but the reality is that through the manufacture of neurotransmitters, neurochemistry, that our organisms within the gut, which are variable based upon our lifestyle choices, are then controlling our behavior. So it's the good news is that you make so clear in your book is that therefore, if you get this, if you understand this, then you could pull levers such that you can change your behavior and make better choices for your general health, your brain health, by going through the lens of the organisms in the gut, i.e., the gut microbiome. And so you make a variety of dietary recommendations, which interestingly are a bit of a modification of a carnivore diet, but nonetheless catering to the microbiome. So perhaps we can just double click on that a little bit on what are the keys of a good diet to nurture the microbiome and preserve the integrity of the gut lining.
Yeah, there are. I've through the years had a number of people who are quite intolerant to almost all plant compounds. Um, and some people accuse me, if you take my lectin theory seriously enough, then I'm probably the father of the carnivore diet, because if certain plants don't like you, then all plants don't like you, and you should not eat plants. I don't say that at all. I happen to be a plant predator, but I pick my fights. On the other hand, I have had a number of people who have used a carnivore diet, mainly beef and pork, and they feel better. They definitely feel better, and their GI issues go away. But I do a lot of deep dive into inflammatory markers, inflammatory cytokines like TNF alpha, IL-6, IL-10. And these guys, despite feeling better, had increased inflammatory markers. And I'm really interested in this sugar molecule in beef, lamb, pork, and milk called Nu5GC. We have a sugar molecule in us called Nu5AC. It's also in fish and poultry. Nu5GC and Nu5AC look identical except for one molecule of oxygen. They're otherwise identical. The lining of our gut has Nu5AC. The lining of our blood vessels has Nu5AC. The lining of our blood-brain barrier, the glycocalyx, has Nu5AC. The lining of our joints have Nu5AC. When we swallow Nu5GC, we make a very aggressive antibody to it. We hate it. What's interesting is we will incorporate Nu5GC into our various glycocalyxes and displace Nu5AC. And the more of these foods we eat, the more it's displaced. And then we attack it as a foreign substance. And what's interesting, even animals that have Nu5GC will not let Nu5GC in their brain because it is so inflammatory. Even an animal who makes Nu5GC. That was one of the big surprises to me. So what? Well, these carnivore diets are based on animals with Nu5GC. So what I did with these people is I said, hey, okay, it's working great. Okay, well, let's not try to get plants into you right now, but do me a favor. Let's start eating pastured chicken. Let's get wild seafood. Let's get wild shellfish. And let's do fermented meats like sausages, which get rid of Nu5GC. And let me retest these inflammatory markers. And lo and behold, these inflammatory markers went away. They were still carnivores, but as I talk about in the last chapter, they're now chicken in the sea carnivores. And so it's convinced me that this Nu5GC issue is real. It's convinced me now for 10 years that this is real.
Well, when we are confronted by or having conversations with, a better way of putting it, a full-on carnivore dedicated only to animal products, how do we reconcile that with the notion that we need fiber to nurture the very gut bacteria that you're talking about?
Well, and I write about this in the book, and this surprised me in my last book. We are very capable of fermenting animal products into butyrate, which really surprised me because, again, these guys remarkably do well, and we can measure their butyrate production, and they've got butyrate-producing bacteria. And I guess it shouldn't have surprised me because Akkermansia mucinophila loves mucus, and traditional cultures, nose to tail eating, they're eating all of these collagenous, mucus products as part of their culture. And one of the things that really shouldn't have shocked me, but when I wrote about the blue zones, the reason they're blue zones has nothing to do with what our good friend Dan would propose, is that these guys are sheep and goat herders. They eat a lot of sheep and goat yogurts and cheeses, and to almost a person, they're sausage eaters. The people with the longest lifespan as a country uh, is Andorra, this little country between Spain and France, up in the hills, and they're sheep and goat herders, and they have sausage every day. And and the best coronary artery disease in France is in Toulouse, the home of foie gras and sausages and cassoulet. And these fermented sausages, traditional sausages are fermented. They have lactic acid bacteria in them. They eat all the new 5-GC. So these guys are getting great fermented products that doesn't have new 5-GC, and fermenting milk removes new 5-GC.
Well, I think another example, of course, would be the Inuit who don't have any access to fiber or traditionally
Traditionally.
until recently, and would eat nothing but fat and meat from the mammals that they would kill. And the my understanding is that their rates of coronary vascular disease, coronary artery disease, were very, very low.
Yeah.
And certainly there may be a protective effect of the omega 3s from the fish, but beyond that, let's just call it like it is. There could not have been fiber what was growing in the Arctic, so for whatever length of time. So I think that does stand as a bit of a conjecture to the notion that everybody needs plant fiber in their gut in order to have a healthy bacteria. I think supporting your claim.
Yeah. Now, do I think that the easiest way to do it is plant fiber? Yeah. And I see that in my patients, but like the Sonnenbergs showed, the husband and wife microbiology team at Stanford, they took volunteers and they gave them a great plant fiber inulin, which is present in artichokes and asparagus and chicory family vegetables, Jerusalem artichokes, and they looked at inflammatory markers and they looked at gut microbiome diversity. And lo and behold, nothing changed. They still had inflammatory markers. They didn't have diversity. And they go, what the heck? So then they repeated the experiment and they gave them fermented foods. In this case, it was mostly yogurts and kefirs. And lo and behold, the combination of the plant fiber plus the products of fermentation, which are postbiotics, then and only then they got improved gut microbiome diversity. And then and only then did their inflammatory markers go down.
Well, it gets back to the rainforest that you talked about, the diversity that allows for resilience, and what is dysbiosis? It's really pretty much a loss of that diversity,
Exactly.
and I think the notion that each of these strains is going to be nurtured by a particular dietary component makes it sound a little bit compelling in terms of how we eat. But nonetheless, I think diversity of our diet is actually a very, very good thing, with the caveats that you've talked about. Gluten-containing foods, and as you would, I think, agree, certainly lectins. But you've talked in this book and in your last book a lot about polyphenols. So, how do polyphenols? What are they, and why do they enter into the picture vis-a-vis the microbiome?
Well, I've been researching and actually presenting papers about polyphenols for about 20 years now. And back in the old days, polyphenols were thought to be antioxidants, and that's how they worked. And really, the head of the Polyphenol Society, Marvin Edis, a number of years ago in Lisbon, when 500 of were assembled, and he got up and he said, "Those of you who think polyphenols are antioxidants can leave the room now, because I have not enough time to teach you what they really are." And everybody, what? And so, and polyphenols we knew were horribly absorbed from our intestinal tract, and people then thought that they cause their effect by being hormetic agents, that which doesn't kill me makes me stronger. But it was only until recently that we realized that polyphenols are actually some of the favorite prebiotic foods that the gut bacteria eat. And the gut bacteria then in turn change those polyphenols into more absorbable compounds. And we just didn't know that that was the middleman. So it was a win-win. Polyphenols are used by plants to protect their mitochondria from sun damage and from environmental stresses. And polyphenols actually are really good at uncoupling mitochondria, and we could spend an hour talking about that. But let's just say they're mitochondrial protective agents. And so, what's exciting to me is if we use bacteria to activate the polyphenols for us, then we can absorb them and they become mitochondrial protective agents for us. What I think is really exciting is that so many foods that we now view as toxic, like, for instance, red wine, um, certainly is consumed in a lot of the long-lived cultures. But red wine, we've allowed the yeast to do the fermentation, the activation of polyphenols before we even consume it. And so they've already started making those polyphenols more absorbable than if we actually did them by themselves. And so many of our fermented foods, they've activated the polyphenols for us already.
Well, you really did a great job in your previous book about just this whole notion of polyphenols acting as mitochondrial uncouplers and how that ultimately is a good stress for us, allowing mitochondria to be actually stronger and better performing in terms of purveying energy for us. So it's a different view, but no, that's taking hold now. How do we get a lot of polyphenols then in the diet to nurture our gut bacteria and allow them to convert them for us?
Well, the obvious reason is so polyphenols in general are these dark, bright colored foods. Um, Interestingly enough, we're fruit predators, and only fruit predators have color vision. Um, us and great apes and bees and so on, hummingbirds. Plants use the color of their fruit to tell the fruit predator when that fruit is ripe and has the most sugar content. And that actually is to tell the predator that their seeds are protected so that they can be swallowed and safely. It's fascinating. Walk through any of the snack aisles or cereal aisles of a grocery store, and you'll notice that almost all the packages are orange, yellow, reds, and that's to attract the fruit predator to pick up that package. That's a signaling
Always
sign.
after me, Lucky Charms.
No, it's that's right. Yeah, um, so we got the benefits of these polyphenols way back when, from these bright colored things. On the other hand, I plead with people there we did not eat fruit 365 days a year. Great apes in the jungle do not eat fruit 365 days a year, and we inherited the gene, the mutation that you well know about from great apes that got rid of uricase, and it allowed us, like great apes, to take fructose and store it as fat for the winter. And that's what made great apes us. And you and I both know that the thrifty gene was actually that mutation. And and you've done a wonderful job of talking about that and telling people that fructose may not be your best friend.
There was a podcaster recently because one of the things that fructose does is it is also threatening to mitochondrial function.
Oh yeah.
And of course it is, but there's a podcaster out who reviewed a podcast appearance where I said what you just said, and he said, "There's never been a double-blind, placebo-controlled trial to demonstrate that." Oh my gosh, I got to leave it there, but I feel kind of good that I got to finally respond in this context. So, what about big question here? And I bet our viewers are on the edge of their seats. What is the role of probiotics in terms of putting things back into the gut and helping with dysbiosis?
So I think one of the exciting things, and I wrote about this in Gut Check, and so dead men tell no tales, but dead bacteria tell tales. And what's really exciting is that the cell wall of bacteria contains incredible information, and that bacteria, again, we'll go woo, are sentient beings. They can read who's in the house, they can see who's there. And we know, for instance, from Akkermansia studies, looking at dead Akkermansia versus living Akkermansia, the dead Akkermansia literally do contain messages that are useful. And the gut microbiome says, "Whoa, Akkermansia is in the house, let's party." So, one of the things that people should be aware of is that most of the probiotics that we eat, particularly in yogurts and things like that, most of those living bacteria, if there are any, probably will never make it past gastric acid. But it doesn't matter. It turns out that these carry important information, and that's actually exciting. So, and I spend a bit of time in this book talking about the bacterial signature on roots and the bacterial signature on plant leaves, and even, God forbid, in grains, that those bacterial signals, those LPSs, are actually instructive to our immune system and to our microbiome, that these guys may not be so bad. We can actually become tolerant to LPSs. And that's actually was really exciting to me, that there's a way around this. And of course, traditional cultures were always exposed to this.
Well, there is after every meal some degree of transgression of LPS to, in a loving way, challenge the immune system as a perhaps a little bit of a hormetic event. And I will say that your comments about living versus dead bacteria are interesting. I was at a event in New York a couple of weeks back and had a dinner across the table from me with somebody in industry claiming that their probiotic was really special because it made its way through the entire GI system alive. And I said, that's not really necessary. And when you look at the clinical results of various probiotic interventional trials that have been demonstrated effective in certain issues like depression, that they don't recover that organism, that strain. They're even when they're labeled, they don't recover that in the stool. And yet, when you start to look at the other organisms in the fingerprint of the gut microbiome, there are absolutely changes that are demonstrated in other organisms. So your point is very well taken, that this notion of it, that we supply X number of viable organisms that make its way through gastric acid, and therefore that's the reason they work. It's not necessarily, and I used to very much glam onto that doctrine, as I'm sure you did. We all did. But as we move forward and we learn things, we correct ourselves. I mean, now we're seeing probiotics manufactured as including the supernatant, which is a dried version of the broth in which they were fermented, because that's really valuable. That baby water got thrown out in the day, but now, because of the very things you describe, it's extremely valuable and being incorporated into various probiotic products. And I think that's a great idea. And definitely, there's a big notion that the viability of this very anaerobic Akkermansia muciniphila that you've been talking about, that there's some golden ticket because there's a company that's able to manufacture it and it's viable. And then when you look at the literature of pasteurized Akkermansia muciniphila, you see some pretty incredible metabolic benefits of that particular organism in dead pasteurized
Yeah.
organisms, just because of the information, as you describe it, the messaging that is contained on the surface of that organism is really quite interesting. Have you explored the notion of bacteriophages, these viruses that are modulating the gut bacteria? What's your takeaway from that?
Yeah. It's interesting. Eli Lilly, believe it or not, started as a bacteriophage company before the times of antibiotics. And I just came back from the meeting of the Society of Extracellular Vesicles in Malta. There is a society.
That's funny because I just got invited to Malta yesterday. That's very weird.
Yeah, that is weird. So the believe it or not, the most infectious agents in our gut are bacteriophages that want to attack bacteria and take over their mechanism of production. And there's so many things that can be done with bacteriophages, including transferring information to bacteria, changing their genome. And a lot of the research is looking into using phages for exactly transferring genetic information. What's really exciting to me, and I wrote about this in the book, is that exosomes and extracellular vesicles contain packets of information, contain DNA or RNA, microRNA, even living mitochondria that can be transferred from bacteria and actually even plants directly into our cytoplasm, directly into our brain. And they can actually be a way of changing our information. And the cool thing about bacteria, as you and I know, I mean, they're constantly dividing, they're constantly exchanging information, they're constantly merging. And if one bacteria has got an antibiotic resistance, he'll let everybody in the room know. And come on over here, I want to send you a text message. And here's the gene sequence to make the antibiotic resistance. And it gets so far as fascinating. One of the most stunning pictures I saw in Malta is, these little viral particles want to attach to a bacteria. A bacteria will make 20 extracellular vesicles, little packets of cell wall, and jettison them when it feels like these viruses are coming, just like a bomber jettisons all this aluminum foil out the back so that the missiles attack the decoys. And you can watch these bacteriophages hop and become stuck on these decoys.
Yeah, the animations are breathtaking.
It's like, this is this world that we were not privy to. And I mean, this is a complex society. And the more, with every passing day, the more we learn about how complex this is and how they're running this machine, uh, is very exciting. Very exciting.
The notion of plant exosomes modifying our DNA is, I mean, that really talks, that's food as
Food for
information.
thought.
That plant exosomes are changing our life code expression is pretty compelling, and it makes you really recognize the power of the plate. There's a company, Viome, Viome, that is using AI, artificial intelligence, to analyze uh, and draw inferences about stool information about the microbiome, oral microbiome as well. And based upon the number of data points that they have accumulated, they are now able to describe, again, fingerprint like microbiomes that correlate to not only disease, but even risk for disease. So it looks like that's where we're going in terms of being able to use this as a data set.
Yeah, no, I hope so. I think that what really will make personalized medicine. Because if you extrapolate Hippocrates, I think a better way of saying is death begins in the gut. And the more,
Oh, I don't want to go there.
well,
Let's,
as the wall of the gut breaks down in C.
that's right.
elegans, that's how it happens. So yeah, I think it's really exciting and we apply these ecological indexes like Simpson's and Shannon's index to the microbiome diversity, and it's really fascinating to watch how we can manipulate that in our patients. And you're right, just to bring back to Akkermansia, I have a number of patients who have a lot of Akkermansia, but they don't produce doodly squat worth of short chain fatty acids, even though that bug is in there. And so you're right, it's far more complex than we could have ever hoped for.
One of the reasons is it requires butyrate, and that's why you do see products that not only have the Akkermansia muciniphila, but Clostridium butyricum to prime the pump, as it were.
That's
But
exactly
one
right.
would think that, if you have we talked about a fiber-rich diet, but you're saying that we can ferment meat and produce butyrate. So, but it's just another example, I think, of how they're codependent, or let's say symbiotic. Codependent seems negative. Symbiotic in terms of bringing about, something that's good for us. I want to thank you for spending time with us. I always love spending time with you and learning things. So thank you again, Stephen. Good to see you.
Great to see you. Thanks for having me, and always great to talk. And I'm sure we'll see each other soon.
Let me again hold up your book, because I think it's terrific, and I want everybody to see the cover. And all the best. I hope we get to see you soon too, as well.
All right. Thanks for having me. I appreciate it.
Bye-bye. What an interesting program. Dr. Gundry explains again this relationship between the gut organisms and what is going on throughout the rest of the body, and draws some significant relationships between the gut and the brain. Again, emphasizing the importance of nurturing our gut bacteria through the various dietary approaches that he talked about today, including making sure that we get adequate fiber to nurture our bacterial friends that make good things for all of us. Well, thank you for joining me here on the Empowering Neurologist. Today, I am Dr. David Perlmutter. I'll be back soon. Bye for now.